Welcome to episode 2 of Devs on the Graph. In this episode, we get to know Alexander Gusev of Spyglass Labs. We get to know a little bit about his background of how he got into the Ethereum ecosystem, Build Guild, also how he started building with the graph, and now how he's building with Substreams and Spyglass Labs. At the end of this episode, he's going to take all of us through a workshop where we can understand substreams and start to build with substreams. So if you're a builder and wanting to know more about substreams, stick to the end of this video. If you're listening to the audio version of this episode, be sure to switch over to the video version of this episode at the end, and you could check out that link in the description so you could watch his workshop. And as a final little bit of housekeeping, just know that Spyglass Labs has recently went through a name change from Soulbound Labs to Spyglass Labs. So in this episode, we're discussing Soulbound Labs. Just know that it's actually currently Spyglass Labs. So without further ado, I give you Alexander Gusev.
Good afternoon.
Alexander Gusev, also known as
Blind Nabbler or
also
Goose.
Goose. He's got all of the different names. And
whatever you want.
Whatever we want. Hi, everyone. This is Marcus, and here we are at Devs on the Graph, episode 2. Ooh. And well, like I just said, we are with Blind Nabbler, Alexander Gusev. And he is with Soulbound Labs and has been so for a few years now, just building. I want to get to know more of that story. But before we get into that, I want to understand you and what brought you into becoming a developer today. So let's start back at the beginning. When did you first start getting interested in computers and building software?
Yeah. So I think that when I think back to like when I first started getting into software development, it was not actually with software development. My first taste of like engineering and building stuff was definitely when I was like a little kid. So I'm trying to think, I was like probably about 9 when I was playing this game on the PlayStation 3 called the Little Big Planet, like Little Big Planet 2. Are you familiar with it? The little sack dude jumping around and stuff.
Yeah.
So that game had the thing that was super cool about that game was not actually the game itself. It was like the game had a really cool level editor. And so basically it was effectively like a whole game engine inside of a game that you could use to like create and publish and share games that like other people could play, and you could download people's maps and like customize it yourself. And it was that like totally hooked me on this feeling of like creation. And like, I mean, I was like 10 years old and homeschooled, and I had a little notebook that I carried around to like sketch up ideas, and never like my brain would just pop up with new ideas. I'm like, oh, I can't wait to like go home and go build that. But then that kind of like lied dormant for like 8 years. I didn't really gravitate much towards like computer science, really. Like I inevitably had some experience because I've been like into Linux for a really long time. So I was like writing bash scripts and, playing around with my computers in like interesting ways, but I didn't really like consider that programming. But it wasn't until like 2020, towards like the very start. It was actually a little bit before I think quarantine hit, but I started getting really into Ethereum and this whole concept of smart contracts. And I was like, whoa, this is super powerful.
Let me dive into that.
Yeah.
What was your first impression of Ethereum? Day one impression when you can look back and say, wow, that was an important day. What kind of day was that for you?
I mean, honestly, I think my first day hearing about Ethereum, I like did not like understand it. It wasn't until I just started spending more time in the ecosystem and like seeing stuff that people were doing. Because like, I don't know, at first like a global computer is like a kind of cool idea, but it's not like immediately interesting. At least it wasn't for me like when I first got into it. But then I was like, okay, this is like super powerful. And I guess also that's like within the context of general like cryptocurrency. Because like I've been in, really interested in cryptocurrencies since 2013 when Silk Road got shut down. It was like my first exposure with it. I was like, okay, that's really cool. We have like magic internet money we can send each other. But it took me a little bit to like fully like click with Ethereum. So I don't really have like a day where I was like, oh my God, I get it. But it was more like a slow like frog in a beaker type deal where I was like, okay, like there's like a lot of really cool ideas here that could be super, super powerful. Like, DeFi is like a really obvious one that I was like, okay, this is cool. Like there's like hyper efficient stuff with no middlemen that are just working off like code. That's really killer.
Tell me
So am I
about.
like allowed to swear on this thing?
You can do whatever you want.
Okay.
We are, just for the audience, we did get a chance to work together back with Soulbound Labs, where I was doing dev relations back then. And the first I heard of you working with the team was through Scaffold ETH. And that was really how you got started, and that is how I got introduced to you. So what was that like, going from Scaffold ETH and using Scaffold ETH, and then also using tooling with the graph and subgraphs?
Yeah, I learned how to do Ethereum development on accident. Like I didn't actually go into it being like, oh yeah, I'm gonna go learn Ethereum development today. I was like I had some ideas and I had to piece together the ways how to do that. But yeah, getting into Scaffold ETH and the build guild was definitely a huge parabolic moment. I don't know. I just my learning accelerated really rapidly, because before I was kind of fumbling around, didn't really understand how anything worked. I was all these tools are kind of cool, but they don't click at all. But yeah, with Scaffold ETH, a super forkable framework for building Ethereum smart contracts was a perfect playground for me to experiment with and learn through experimentation, as opposed to learn through reading, which I don't do particularly well. I much prefer to get my hands dirty in this sort of thing, and when it comes to this sort of stuff. So yeah, basically it was through Scaffold ETH that I was able to learn smart contract development and front end stuff, and put all these together. And then I started working with the graph a couple months later, because I got hired to do a little bit of contract work, which I got exposed to subgraphs with, and I was like, oh, this is actually really cool. You have these GraphQL front end, or GraphQL APIs. I was I don't really know what GraphQL is, but I kind of understand, I can make these queries which can fetch different sorts of data. And then, through experimentation, I learned how powerful they were, I guess.
Very cool. What has kept you going? Right now, you are hopping from, fundamental Ethereum concepts, and now you're looking at different ways of using APIs that are subgraphs, and now you're building with Soulbound Labs. And I do want to talk more about Substreams, which is something that you've been building with lately.
Yeah.
What's a thread about yourself that you find is, wow, Alexander Gusev, I'm going to keep on going every single day? Is there something that is a North Star that you would like to see in the world or in the Ethereum community, or is it for yourself? I'm just curious what motivates you.
Yeah. I mean, so I'm very involved with the Build Guild, which is very closely tied with Scaffold ETH. It's a group of developers who all use Scaffold ETH. And so, I'm very motivated and propelled by my peers there, because it's nice mentoring new developers. It's nice seeing what other people are doing and this sort of thing. But I think mainly it's just I'm just having fun. I'm just building things. I don't put too much pressure on myself to do anything super crazy. I just kind of am okay, this is a pretty cool idea. I'm going to go play around with this. I'm going to go work on this. I tend not to put too much pressure on myself in terms of I have to go change the world today, because that's tough.
That's a lot.
That's
you
also,
can do one thing at a time.
Yeah,
one
exactly.
thing at a time.
So if I feel I can perform optimally, if I'm playing, so to speak, I'm a big proponent of learning through play and experimentation, that sort of thing. So yeah, whatever kind of helps me play. Yeah.
Before we get into Substreams, I want to ask if you could share with any new developers in the Ethereum environment, what from your learning would you like to share with them about your journey, and maybe something that might accelerate them in terms of developing with the graph, developing with Scaffold ETH?
Yeah, I think that development, it's a loaded question. What kind of advice?
Maybe what would you tell yourself? That would be a better question.
Yeah, I think that I would say again, yeah, don't put too much pressure on yourself. Learning is a very incremental process. You don't wake up one day and you're oh, I get it. I know how to develop smart contracts. It's no, you have a problem you need to solve. So you learn about what it takes to solve that problem. And yeah, just figure out what you want to do, and then find a way to make that happen, and then learn from there. It's very easy to get caught up learning and gathering information, because it feels very productive. But ultimately, I think it's a lot better to have a goal and like work backwards from that, seeing like what you need to do. And, you know, in that same vein is it's really useful to have, you know, I guess like references. So I really like this dude, Paul Graham. Are you familiar with Paul Graham?
No.
So he's like a founder of the Y Combinator startup accelerator, and like he also had a startup. I think he actually had a number back in the day, but he has really good essays on his website. Everyone should go check it out if you haven't checked it out already. But he specifically has a pretty interesting story because he actually went to art school after getting his undergrad in computer science. So he went off and did his own thing at art school. And he has this really good essay called Hackers and Painters, in which he describes hackers and painters as seemingly two very different things, but actually they have a lot of things they could learn from each other and a lot of ways in which they overlap. And I think one of the really killer pieces he said there was like, artists don't learn to do art by just doing art. Like some of them do, but very, very few do. A lot of them do art by mimicking greats and like copying, because you learn about the intricacies of the development process and the intricacies of like painting. I think a lot of that ties over very well to learning development, because like it's really easy to kind of like reverse engineer something. If it's like, okay, I want to go, build a clone of Uniswap. Like, okay, I can work backwards from there super well, and I learn about DeFi, and I learn about all these different things, and then you go build your clone. So I guess it's very useful to work from references and work from other people's stuff. So like find good examples of really cool things that you would want to do, and then try and clone them and modify them in slightly different ways.
I love that. And play. I love that attitude, and don't put too much pressure on yourself. And that's for myself and everyone else out there. Not too much pressure on yourself. Let's go into substreams.
Yep.
You started, correct me if I'm wrong, you started learning Rust just because of substreams.
Yeah.
Tell me about that journey, and tell me now that Substreams are now, the docs are now live on thegraph.com, and then also you can go to Substream's Streaming Fast website, and they have the docs there as well. Go ahead and dive in if you'd like, but I want to hear about your journey where you started years ago, maybe 1 year ago, a year and a half ago with Rust?
Yeah, it was about a year ago.
About a year ago?
Shortly after Graph Day.
Gotcha, shortly after Graph Day.
We got demoed at Graph Day, and I was like, oh, wow, this is like, that's cool. That's very cool. I can't wait for that to be a thing.
Cool. So where are you at with your Substreams development journey? And what would you like to tell the audience in a few words? What could Substreams provide for them?
Oh boy, Substreams can provide a lot. They are really, really cool. And, I guess there's like two ways in which I could talk about Substreams. So I can talk about it in the context of like an existing subgraph developer and like how Substream solves so many of the pain points of subgraph development. And
Substreams, as is, are Substream powering the subgraphs. So they pipe into subgraphs.
Yeah, I guess actually a really important first thing is like, let's define what the hell even a subgraph is.
Perfect.
A substream. So many sub words. Substreams are just a data transformation layer they're a transformation layer for blockchain data. Again, what does that mean? That's like not a very good, that's like some mumbo jumbo, right? So basically it is a way to take an input of some block data and modify it to either extract certain types of information that we care about or aggregate certain values, and basically a way of finding a needle in a haystack, so to speak. I like this analogy where we can kind of think about, we have some data that we want to find, but it's hidden in a bunch of other data, within block data and whatnot. Said data a lot there, but this is also very similar to kind of what subgraphs are doing, but substreams are not really concerned with how to store them and how to serve this data. So they are simply concerned with, we have data over here and we need to manipulate it in some way because you have to do something with it at the end. So they're just worried about transforming data. So you can use Substreams to spit data out into a Postgres database to use in a GraphQL endpoint. And so this is what the graph does with Substream-powered subgraphs, which are super, super cool. Substreams at their core, they just transform this data and manipulate it in some way to be consumed by some endpoint.
Right. And correct me if I'm wrong, but the Substream availability of the data is coming from Firehose, and you're getting that.
Yep.
And then from there, that's being piped into the subgraph, and you're being able to get that data much faster in terms of the speed of indexing. And then also you're getting much more granular data. How has that changed your development with Soulbound Labs?
It's changed it a lot. So I guess you mentioned something that's also pretty important to talk about with piece of how substreams work, and that is Firehose. So substreams are built with a streaming first, or I guess they are built to be have data streamed through them. So traditionally, how things worked with subgraphs was we had an instance of Geth, which is the Ethereum node or Ethereum node client. Sorry, Ethereum client written in Go, and within Geth you have RPC calls. So these are kind of like API calls you can make that will get certain information. So an example of this is like ETH get balance, which can take a parameter of an address and it will return the balance of an address. And so this is very simple. You make a request, you get back your data. But the problem with this is RPC calls are slow and they can't be like parallelized very well. Firehose is much faster. Honestly, actually, I guess not.
Well, from what I understand, not to interject, but from what I understand, Firehose allows for a flat file representation of the entirety of a blockchain, where the blockchain itself is not having to actually be interacted with. You're actually just interacting with Firehose, and that allows for the parallel rapid indexing to be piped in through substreams. Okay,
that's interesting. Yeah, no, I appreciate that explanation. Yeah, I just kind of consider it this magic black box that allows me to get data very fast. Yeah, no, I think that does sound super correct. But yeah, basically, the way that Substreams works are they have restrictions, but these restrictions actually are not restrictions. They're not restrictions like in a bad way. They kind of force you to write better and more easy to understand code, in my opinion. So Substreams has a concept of modules. And so the whole architecture of how your data flows has to be deterministic. And so what does that mean? If you're familiar with like math or anything, there's a concept of like pure functions, which just give some output based on some input. And determinism is if something has the same inputs, it'll always produce the same output, right? So if I have a function, f of x is equal to 2x, it'll always return 4 if I give an input of 2 because it's multiplying 2 times 2, right? It's not, there's no like sense of side effects there. And so with Substreams, all of your modules, which start off initially ingesting some raw block data, have to filter it and do something to it. But the nice part here is that we're not concerned with like ordering of blocks or how this works. We kind of just shove the data through this pure function and it gets manipulated in such a way. And so, as a result, we can't do the same. We don't have like the same level of freedom as far as like, oh, I'm going to go grab this entity at this ID, like we do in subgraphs. But as a result, our data or our code is much easier to read and much easier to reason about because if something breaks, we kind of more or less know where it broke. And we can also, visually see, like, because actually Substreams is a really nice graphing utility that we can actually see how substreams or like how modules are used to feed other modules in this chain. And so, yeah.
With Soulbound Labs, I know you guys have been working with subgraphs for a while, and now with Substreams, how is that providing you guys the data in a different way, and how is that making your DApp different?
Yeah, so because Substreams are able to be so fast because it's all deterministic and it can be parallelized super well, it enables us to get a lot more creative and a lot more powerful with like what kind of data that we can index. So traditionally subgraphs have been pretty slow. But with Substreams, it's a lot faster. And so, we can now do things that we were just technologically limited to before, which means we can do a lot more complex calculations within subgraphs to give people like reputation score, or even just more complex stuff in general. And so like, this example isn't really specific to any of my stuff at Soulbound. This is like my own personal playtime working with Substreams. But I built a Substream to index every single contract that was ever deployed to Ethereum mainnet.
I saw that.
Yeah, which is like, that's like a ludicrous thing to possibly do. But alas, another good example is like I built the ERC 721 balance thing. It's like kind of, I guess it's like an ERC 721 tracker, but it tracks every ERC 721 ever deployed on mainnet, and gets like everyone's balances and stuff. So you like, can use that to fuel your NFT marketplace or whatever else. And these things are just not possible with like normal subgraphs.
Right. And then that granular data coming in faster, it allows, from what I understand, what you guys are tooling with, and you have a presentation, by the way, if anyone's listening, there's a presentation coming up on June 15th at the House of Web3 that you'll be presenting at surrounding Substreams and what he's been building with subgraph-powered Substreams. the GUI that you have at Soulbound Labs, what's that GUI doing, and how is that presenting Substream-powered subgraphs?
Yeah, so I guess there's a couple things I could talk about here. So I guess simply to answer your question, this GUI is built with the intent of making substreams and specifically substream development much more user-friendly, because there's no real reason for it to be, access limited to a small group of people, because like people will have data that they want to access, and we should make it accessible and easy to use, right? And so we think
I absolutely love that. Not to interrupt, but
Yeah,
ease of approachability is so critical. It's the same thing that got you into Scaffold ETH.
Yeah, exactly.
That can be a launching pad for so many developers out there who, let's say they want to understand subgraphs, substream-powered subgraphs, to be able to visualize it and say, that's real time, that's happening, and being able to actually have that. That's such a powerful thing that I personally think can provide a jump-off point similar to a Scaffold ETH type of moment for you.
Yeah, totally. And I think it's not necessarily that these new developers are maybe incapable of writing the code to do this, because, it really, the Substream module code isn't anything too crazy, but there is this panic that sets in when you're a new developer and you're staring at a blank terminal and you're like, oh my God, what am I supposed to do? Right. And it's it's a lot nicer to have a little visual playground than have suggestions of what you can do. Okay, I can take this block data and I can filter it out, or I can put in this NFT contract and I can say, okay, I want to see all transfers where the from address is vitalik.eth or the to address is vitalik.eth. And you can kind of visually piece these sorts of things together. It's really important for, I think, Substream adoption. Hopefully, anyway, it'll get more people using this really powerful technology.
Awesome. That's awesome. That's awesome. So I think I've gotten to know you once again, Alexander. We've talked for a while now, not just now, but for the past years. We've gotten to know each other. So I really just want to thank you for your time.
Yeah, of course.
The next steps for you, next steps that you're excited for, what's something that excites you, what you are building, and then for the coming months, coming years, what's something that you're just man, I'm really, really excited about? It doesn't have to be anything about substreams, subgraphs, the graph. What are you tinkering with that you're just oh my gosh, this is fun right now? I know you're drumming right now.
Yeah.
That's awesome.
I do play the drums. It's super fun. My poor hands are just getting demolished with all of my hobbies, also in the rock climbing and drumming, and also furiously programming for many hours a day. I would say substreams honestly are some of the most exciting things for me. I would say within the space right now is a lot of cool ZK stuff that's going on and scaling stuff. But I think that we're approaching a point which is rather, I don't think anyway that we've had, which is that these decentralized technology options are becoming better. We're achieving decentralized supremacy, so to speak, where the decentralized technology options are becoming better than the centralized options, which is pretty crazy because traditionally it's been a sacrifice. It's okay, do I care about my data correctness and do I care about this being good? It's okay, I'm going to choose a decentralized option like the graph because I really care that my data is correct. But if you don't care so much, you can go to another provider or something. But with Substreams, it is so fast and so composable, which is something I'm also really excited about. It's because of Substream's modular architecture, you can import people's packages and use their modules. So you have this whole ecosystem where you don't have to write everything from scratch. You can just use people's packages and plug them in and it all just works, But yeah, with Substreams, basically data indexing is going to become so good and so easy to do and so fast that we're going to have a Cambrian explosion of indexing data on chain, which I think is going to be really, really cool because we're just going to be having so much good data available out there to help developers build things better, which is super exciting to me. So
I love that. I love that you are bringing up Cambrian explosion and how the actual decentralized layer of so many different types of technologies that are in this space, Web3, decentralization, including the graph, including all of these different blockchains. It's now, in your opinion, comparable, if not better, than certain options. And I really am excited for that.
Yeah, no, I think it actually is just going to be better. Because for instance, I think like Alchemy has some nice stuff where you can, they have like an NFT API where you can get all NFTs a certain user owns and whatnot. But now we're going to have these equivalents and more be decentralized, and like, anyone can add on and make their own forks, and it's great. It's like we're getting really powerful APIs built on top of raw blockchain data, which is sick. So
love that. I think it's a great place to close it. So that was Alexander Gusev with Devs on the Graph. I've been Marcus, and I thank you for taking the time for joining us. And if you stick around, Alexander is going to be bringing us through a little workshop that he has prepared. So if you could stick right through this, go ahead and continue the learning with Alexander. And once again, thank you for your time.
Thanks.
Hello. My name is Alexander Gusev. I'm from Spyglass Labs, and this is now the Substreams overview workshop section of the talk. So we're going to be going over substreams, and as a result, we have some prerequisites for what you guys got to know. So you have to have some level of general Web3 knowledge. You don't have to be pros, but you also don't have to be a noob. And you're also going to have some understanding of programming. You don't have to be an expert developer, but ultimately this is a programming talk, and as a result, you have to know a little bit of programming. So you guys are going to walk away from this workshop hopefully with some pieces of information. These pieces of information are: what are substreams? So by the end of this, you guys should be able to answer this question pretty clearly. You guys should be able to answer why substreams are so epic, because they are super epic. You should also know how to build a substream, kind of the process of building a substream. And then you should also know that decentralized APIs have, in my opinion, now reached the point of supremacy over their centralized APIs. And there's a couple of reasons why I'll talk about this, but we'll talk about this in a sec. But I think it's really important when talking about any sort of technology exists to solve some problem. And so let's go over kind of the problem statement for why substreams should exist and why you should care in the first place. Blockchains are open, and all the data is there out in public for any of the node operators to have. However, digesting the raw blockchain data is hard and complicated, and finding the data you care about, let's say, for whatever your application is, can be pretty difficult and convoluted to do. And so let's kind of put this in more common developer terms. So let's give an example. We have our developer Bob, and Bob wants to build an app that shows all the NFTs that a user owns. So how does he get this data? Well, he has some options. So he can run a full node and query the chain directly for the event logs, which is fine, and it's really the correct quote-unquote decentralized way to do this, because he has the nodes and he doesn't have to trust anyone with his data, and he knows that all of his information is correct. But again, this is A, very complex to do, and then B, you still have this needle in the haystack problem where it's just difficult to get the data you directly care about. You can also use a centralized provider rather than running your own node, which is fine for the most part. They have, centralized providers are a legitimate risk for the ecosystem, because if left unchecked, they could become the next AWS, where we have 3 companies controlling, 95% of what the internet runs on. But for now, they're fine. You could also use a centralized data indexing service. So this is kind of like a blend of custom data tracking as well as centralized providers. And kind of examples of these are things like Dune or some of these other data analytics services. Or you can use a decentralized API. But before we get to that, let's talk about centralized providers. So companies like Infura and Alchemy, they provide traditional API endpoints that allow users to access information from the chain. So these are, basically easy to use endpoints to do things that developers care about. The developer experience is pretty good with these things. I mean, I've used them. I think a lot of people use them. Most people probably use them. If these aren't sufficient, they are ultimately, at the end of the day, providers. And so you can definitely use them to just listen to event logs as well. So examples of like the nice kind of wrappers they have to get the data you care about are, for instance, getting all the NFTs that a user owns. So you send it an address and it spits back some big array containing all the NFTs they own. Or also getting token balances for the user. So you don't have to process this directly. You just have these ready to go endpoints. And so why would someone go with this? Well, the reason why is because, one, and this is the primary reason, is it's just easy. So they're very easy to use because everyone, or most developers are used to using APIs to get their data, and so this is very intuitive. And also, I guess it's cheap as well. However, there are also a number of cons. The first is that they're opaque. So we don't really know how they're getting their data. We don't know if they're omitting certain data or whether or not they're sending you bad data. You don't know. They also can't be customized. So you can't include like a whitelist or a blacklist or add some extra info or add some extra derived info. What you see is what you get, and you can't really play with it at all, which I don't like. I like customizing my things to make it kind of work perfectly for me. They're also centralized, and so I spoke on this a little bit, and so they are centralized providers, which definitely could become the next AWS or Google Cloud, and I'm not going to talk on this because it's not the primary focus of this talk. And then the last piece is kind of, there's no guarantee over the correctness of data, because again, there's no like signature they're being, you're receiving in accordance with this. You're just kind of trusting that they're sending you the correct data. And most of the time it's not critical if they send you bad data, but nonetheless, still an issue with them. And so now let's talk about decentralized API services. So there are protocols that exist, such as the Graph, that allow for decentralized APIs to be built. And so the way the Graph works is it's a network of people that are called indexers, and these indexers are node operators, as we can kind of see here in this diagram, right? The center person. And basically users define custom ways to index blockchain data. They deploy it to the network, and any number of indexers can pick up this specific configuration and start tracking the events that we care about. And so an example of this could be, getting all the owners of a particular NFT collection and deriving some extra data in there. Because really with subgraphs, you can do just about anything. You can do really complex subgraphs and index a lot of data. And then it's served to the user through a GraphQL endpoint. And so in my opinion, this has the best developer experience once the subgraph is created, because working with GraphQL really is incredible. The queries are really simple. You just describe the data you want, and then it delivers it to you. And it really is killer. So here's an example of how you would get all NFTs that a user owns. So you would query for a particular user, you would pass in their address, and then you would grab, let's say, all their NFTs. You would grab their contract address as well as the token ID. And this is awesome. And so it'll return an array of or it'll return that particular user with an array of all their NFTs they have. So, let's have the pros. You get fantastic developer experience at the final end of the stage. I am going to talk about this a little bit. GraphQL is awesome. Super cheap to query. The Graph is the cheapest network per query, I believe. I don't think there's anything cheaper. It's super configurable because at the end of the day, it's user defined. So if you want to modify your subgraph to do something or add another contract, you can totally do this. What it indexes is 100% up to you. It's decentralized, which is always good because basically we just don't want big centralization of data. And then also we have a very high data correctness on the Graphs network because there are penalties in place for people serving bad data. So if a Graph node indexer can be found to be serving false data or bad data or malicious data, they get penalized because in order to be a Graph indexer and serve data, you have to put up an actual stake of your cache. But it's not all sunshine and rainbows. Let's talk about some of the cons. Assembly script is terrible to work with. I say not fun, but it's really not fun. The compiler errors are just really rough in that language, and in general, it feels like it's just not really production ready, frankly. As well as the tech can be really hard to learn within the Graph. It's ultimately a pretty complex protocol, and understanding how all the different parts work together is hard and requires a lot of info. It's a lot more complex than querying an API. Complex subgraphs can be a nightmare to write safely because of data mutability. There is some things that make this easier to do, such as the really cool, I believe it was by Float Capital, they made a unbreakable, quote unquote, unbreakable subgraph package, which added some nice helpers to write subgraphs in a way which was a little bit safer. But ultimately, they're not they can just be pretty difficult to write. Like handling large, complex, mutable state is always difficult in any sort of programming problem, but especially in subgraph land. You also can't compose it with other subgraphs. This is a con compared to substreams. This isn't really a con compared to the API stuff, but nonetheless, I still think it's it's one of the downsides. And then also, like, traditional subgraphs can be really slow to sync because they sync linearly. And so we'll talk about parallelization and why that's all possible with substreams here in a second. But now let's talk about substreams a little bit. So let's talk about rewriting all of your subgraphs in Rust, because that's what you should do. Subgraphs were not all sunshine and rainbows. The developer experience was far from good. But then about a year ago, Substreams was born. It was a new method for indexing blockchain data. It was built for parallel processing in a streaming fashion, written in Rust by some super cool people at Streaming Fast, which is a core dev team from the graph. And you can clearly tell by this picture of two astronauts sitting next to each other with their appropriate logos there, right? So Substreams brought with them a number of interesting things. So they brought composability, modularity, and insane speed increases for data indexing, upwards of 50 to 100x in certain cases. If we want to give an example of how insane 50 to 100x is, let's assume that your commute takes 10 minutes to get to work. It's not like a super long time. If we were to 100x your commute speed, that same commute that took 10 minutes would take 6 seconds. And that is a crazy speed up. And so let's dive in and see what makes Substreams so epic. So first and foremost, Substreams are fast. Actually, I just gave this. I forgot that it was in this slide. But we have a 10-minute commute, will 100x your commute speed, and it takes 6 seconds. So this means that things that were bottlenecked by performance are now possible. A great example is the Uniswap v3 subgraph, which took 3 months to sync linearly. But when we parallelized it with Substreams, it was able to only take 50 hours, which is really cool. They're also modular. So Substreams work by having little WASM modules that are composed to extract your final data that you're looking for. And for those who don't know, WASM is short for WebAssembly, which is a very fast assembly language for the WebAssembly. And specifically, this is kind of like the environment that the code is written in. And inside of Substreams, there are 3 types of modules. There are sources, things such as blocks in its data. You can say that they aren't directly modules, but I personally consider them modules, so I'm just going to call them a module. Then you have maps, which are modules which take input, or an input or multiple inputs, and they output something. So this is very similar to a pure function for any of you that are familiar with functional programming. And then stores. So stores are key value stores that enable you to aggregate values from maps. So let's look at a simple diagram. So here we can see up at the top that the source module is a streaming fast Ethereum type V1 block. That is just a long way of saying this is an Ethereum block. This Ethereum block is being fed into the map withdrawals map module, as well as the map deposits map module, which are then being fed into the store module of counters. And so you can very clearly see how the data is flowing from the initial block and what parts it's touching along the way. This is really cool for a number of reasons. So I talked a little bit that subgraphs, when they get complex, can be really difficult to write because of mutable state. This does not have this problem because all side effects of your code are restricted to the appropriate module. So the map withdrawals module can never talk to the map deposits module because they're just two different things. The only thing the map withdrawals module is going to be working on is the block data it's getting in, and the only data it will be affecting is the data it's spitting back out. And so everything is very contained, and so the developer experience when working on complex substreams is much more enjoyable, in my opinion. So substreams are also composable, and because substreams are all modules under the hood, we can import other people's modules and use them out of the box. So this is really cool because this means that I can build a substream that extends another user's substream without needing to rewrite it myself. So in subgraphs, if you wanted to do something similar, you would have to rewrite or reuse all of their code directly. Whereas here, we can use an import statement and just import their S package, which is a special file format meant for streaming fast packages or substreams packages. And then we have access to all the modules directly. So we can use the Uniswap v3 modules in my Substream if I felt like it. So let's go over a quick overview of a simple Substream now. You guys are Substream experts. Let's actually dive into some code. So if we go over here, we can see, whoops, if I pop over here. So this is what a module looks like in Rust code. And so let me make this a lot bigger so we can see. Right now, you guys only need to focus on this particular block of code. So this line up here is we're saying this function that follows this declaration is a map module. And so this is a function that takes in a block, which is an Ethereum block, and it's going to return a contracts object. And this contracts object I defined in a protobuf over here. And so I can actually just pull this up. And we can see in here that I defined a message called contract, which is very similar to an object or struct or any of these other type of data format. And so in my Substream, we're tracking all contracts which have ever been deployed. And so for me, I only care about the address of the contract that we posted, as well as the timestamp of when it was deployed. So going back to the module and how this all works, we have our contracts variable, which is the result of all the blocks transactions. We then are going to iterate over the transaction within all transactions within the block and all function calls that are within this transaction. It's a little bit complex, but basically you can think about this as just looking to see every type of transaction that was ever called within every block. We then iterate over it until we find a call, which is a call type of 5. And so in our case, this call type of 5 represents a new contract being made. Don't ask why, it just is how it is in Ethereum. And then from there, if we find a call, we're just simply going to map the call data directly over to then form our contract type. So we take the address, so we grab the call.address and we paste it in here, and then we just get the block.timestamp. And then we collect it all into an array and we export it all and we say, okay, this is all good. These contracts are all of these contracts. And so that's cool. This is a really simple Substream and it all works beautifully. And we can even output it into a substream or subgraph here, but that's not super important to discuss right now. This is really kind of supposed to just be a high level talk. Cool. Hopefully that'll make sense to everyone. Now we can move on to one that's a little bit more complicated. So rather than our 30 line long Substream, let's look at the Uniswap v3 Substream, which is 1,300 lines long, almost 1,400. So we're just going to go line by line. I'm just kidding. We're not going to go line by line. This is a perfect time to showcase one of the really cool things about Substreams, which is how polished the developer experience is. Let's say you're doing some work on this Uniswap Substream and you're like, wow, this is a lot of code that we're looking through, because it is a lot of code and it's very complex. You only care about one specific thing. Well, there's a very cool thing that you can do called the graph command. So if we pop open this and we just go to, we have to go into the module real quick. Let's go to Substreams and Uniswap v3. Substreams Uniswap v3. We can run Substreams graph. Let me make this bigger real quick. Okay, so we can run the Substreams graph command, which will read the YAML declaration, and it will generate this file for us. And so we can pop this open in the editor, and we can see very easily, this is pretty complex subgraph, but we can see how all the modules are connected. So we can see this Substreams block is feeding into this mapping pools created, which is going into this map tokens whitelist, which is going into here, and blah, blah, blah. And let's say I care about this store tokens module. If I want to find some data from the store tokens module, I can now go back to my editor and I can pop this open and I can look for store tokens, and there it is. This is the module that I care about. It's on line 124 and I can modify or touch this part of the code base, all fine. And all of a sudden I'm able to very quickly read through a 1,400 line program because I have a visualization of it all. And that's really cool. And so let's pause this here. All right, and so kind of the final part that we'll talk about, which is just a really cool feature that I've been playing around with a lot with, some of the stuff we're doing at Spyglass, is parameterized modules. So modules have inputs that, like we said, however, modules can have, or map modules can have inputs of either sources, such as Ethereum blocks. They can have inputs of stores, which are those aggregation modules. They can have inputs of other maps, which again are just more data transformations. However, there's actually a very, very cool new module input, which came out recently. Thank you, Streaming Fast, for building this. And that is modules params of, well, I guess it's module input of params. And so what does this actually mean? Params are just a string which is passed into a module. That sounds really not that cool, but it is a string. And what does that mean is we can actually do almost anything in these param strings. So a really good example of what this enables us to do is have really flexible and dynamic modules at runtime within a substream. So rather than having to rebuild a substream every time that I switch a contract that I'm indexing, we can get creative with how we're using module params. And you can see here, we have this public function called map events, and this takes in a param of a string and a param of a block. And it returns something called a hot dog. So hot dogs are kind of a joke that we wrote. I mean, it's not a joke. I think it's actually like reasonably clever. Let me pop over to hot dogs. So hot dog types are, everyone knows what a hot dog is. You kind of know the shape of a hot dog. It's a cylindrical piece of meat that you eat. However, no one really knows like what's inside of a hot dog, because it could be beef, it could be pork, it could be possum. You don't know. And so we called this type of hot dog a hot dog because it's effectively a dynamic type inside of substreams. And so rather than strictly defining a protobuf for all of our different types, such as a transfer event, we just instead have these modules take hot dogs as inputs and outputs. And so we let the users that are using these modules customize how to handle running with hot dogs at runtime within their modules, as opposed to being really strict about it. And so what does that really enable us to do? Well, it enables us to do some really powerful things. So this map events module takes in an input string, as you can see here, of type, or of an address separated by 2 ampersands with a contracts ABI. And what does that enable us to do? So basically we can create a hash map, which goes from an address to an ABI, by just parsing the string that we put into it. And so all of a sudden, this module is able to map every event that a particular contract has, and the contract does not have to be defined until we go to run the module. And so this means that by introducing a param of string, we get super flexible modules. And again, we can compose these modules. So you can use this map events module inside of your subgraph or substream to kickstart the process of building it. And this idea, I think, is very interesting and really cool and very powerful, especially because of all the composition that we're talking about. And so one of the things that we've been working on a lot at Spyglass is building out a big repository of reusable modules. And so I have it all inside of this literate programming document, but you can see that in here, we have all these different modules. And these are kind of, this is a very small selection, but we have modules to, let's say, track all contracts that and see how much gas they're using. We have modules to mimic the overview of Etherscan. We have modules to count unique users that a contract is working in. We have modules to get random NFT prices based on Blur. We have NFT price modules of all sorts of kinds and generalized event parsing modules. And this is all possible because of the ability for us to pass in params, because we can customize how these modules operate at runtime. And so we can give a little example if I pop open this little run command, and we can actually go use some of this. So for instance, to get an Etherscan overview of some contracts, I actually don't know exactly which one this is, but we'll find out. If we go to run it, we can see that we will get a list of all the transactions that a particular contract has interacted with. So we can see an EtherScan overview, which has a from value, a method that they called, as well as a to. So I believe this is tracking the Blur contract address, and this is just getting all of the times that people have interacted with it. So this person, 0xECC953 blah, 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 they called the execute method on the Blur contract at this particular time. This dude did as well. And then there was a 4-block gap, and then these guys did. And people call execute, this guy called bulk execute, but ultimately we're able to parse the API completely at runtime and do really cool stuff like that. And if we were to say, let's say we didn't care about the Blur contract, let's say we wanted to modify this to be the, I guess let's pass in, let's see, I don't want the Blur address, I would like the Lady address, let's say, or yeah, board API hub address as well. Let's just paste this in real quick. So let me delete this, and then we will rerun this, and we'll see that again, there's no compilation that's going on here. We're just modifying how the function is being used, and we can see that somebody called a safe transfer from method on the board API club contract, and this was the guy that called it. And I think that is really powerful, and I hope to see a lot of people building really cool stuff with these parameterized modules. So yeah, I have plenty of other things that I could show you guys, but we'll have to wait for another video or something like that, because at this point, I think that we're kind of running out of time. So thank you very much. I hope you guys learned a lot, and let me know if you want any help building substreams, or yeah, so thank you. Bye.